right, everyone. Welcome back to the land of Chem. I am your host and the author. My name is Jeffrey Drum. Thank you all so much for joining me again. All right, everyone, welcome back. This is episode 26. Hydrochloric acid and the Central Pyramid of Giza. So in today's episode, we're going to be revisiting the industrial scale chemical manufacturing process that was occurring inside of the Central Pyramid of Giza. And this will include a review of the chamber configuration with a comparison of a laboratory apparatus that can accomplish the exact same chemical reaction. We're also going to review the chemical equation with the reactants and products, and I'm also going to present some demonstrations and experiments which show this exact same chemical reaction occurring. I think you all are really going to enjoy today's episode. Just want to say a quick thank you to all of the new subscribers here on the Land of Chem YouTube channel. You all are awesome, and I do this for you. If you like the material, please subscribe to the channel. Leave it a like if you like it. If you have any questions, comments, feedback, please leave that in the comment section below. I think that is it for the intro. So without further ado, let's get right to it. All right, everyone, here we go with tonight's episode. So we're going to start off with a quick review of the configuration and components of the Central Pyramid. So here's a few pictures from my most recent 2021 research expedition to Egypt, just so you can get a sense of the scale of this pyramid. It is one of the most impressive things that I have seen in my entire life. Now, on this diagram, you can see the internal components of the Central Pyramid. Now, if you haven't already, I highly recommend you watch episode 21, my research expedition recap covering the Central Pyramid of Giza, to get fully brought up to speed regarding the configuration of this structure, and then come back and watch tonight's episode. But long story short, we have this satellite pyramid here on the south, which is responsible for the operation of the two stone valves inside of your reservoir intake shafts. So here inside of the pyramid, you have your primary reaction chamber here in the center of the structure, and your extraction chamber, which is located here. And here is possibly my favorite picture of the Central Pyramid from my 2021 research expedition, again, just so you can get a scale of the size of this structure. But you'll notice here on the eastern side of the pyramid are the incredibly deteriorated remains of the Central Pyramid's Eastern Temple. And I'm going to be discussing this Eastern Temple in a later video. But you can see here in this picture, this is a small group of people standing of the pyramid, and you can see just how tiny they are in comparison to the structure itself. It is absolutely overwhelming to be up close and personal next to this pyramid. One of the coolest things I've ever experienced. And here is one of my favorite old diagrams showing the internal components of the Central Pyramid. You have here on the south side of the structure that satellite pyramid which operates the stone valves inside of the pyramid. There is nothing that remains of this satellite pyramid today. It has been completely destroyed. And if you didn't know that it was there originally, you could walk all around the plateau and never even notice that there was anything there. Inside of the structure itself, you have your primary reaction chamber here in the center of the structure. This is your extraction chamber here in the lowered section of this shaft system. And these are your reservoir intake shafts, which are utilized to introduce water from the exterior reservoir to the internal components of the system. And here is one of my favorite 2D diagrams of that internal configuration that I just showed in the previous slide. So this is your primary reaction chamber here in the center of the structure. This is your extraction chamber here in the lowered section of the shaft system. And as I mentioned before, these are your reservoir intake shafts, which are utilized to introduce water into the structure. And in the next few slides, I will show some unexcavated cavities and some shaft systems that are located inside of the primary reaction chamber that are not described or depicted on any diagrams, but they are most certainly located inside of this structure. And the first of those unexcavated shaft systems is located here along the southern wall in the lowered section of your primary reaction chamber. And I hypothesize that this shaft system was utilized to introduce your saturated sodium chloride solution into the primary reaction chamber at the beginning of the production cycle. It was then utilized at the end of the manufacturing sequence to remove the dissolved sodium bisulfate byproduct solution from the primary reaction chamber in preparation for the subsequent production cycle. All right, and next up, I'm going to show a very unusual cavity that is located here in the upper northeastern corner of your primary reaction chamber. And I describe this as a very unusual cavity because it does not appear to have been chiseled away out of the limestone. It looks as if the limestone were eroded or perhaps dissolved away. And I use that word very specifically. It looks like the limestone has been dissolved away because I hypothesize that this shaft termination is perhaps how your sulfuric acid was being introduced into the primary reaction chamber. So you can see here, this cavity is very, very eroded away from the limestone. Again, there is no indication that this hole was actually chiseled out of the stone. And you can see here at the very bottom of this cavity, there's a section here that has been completely filled in with modern concrete. So there is something about this cavity that they are trying to cover up. Again, I don't think that this is carved out of the limestone. It looks like this has been eroded or dissolved out of the bedrock itself. A very, very unusual cavity indeed. And in this picture, you can see, again, that section that goes down here that has been completely filled in with modern concrete. And next up, I'm going to show a pair of shaft systems that are inside of this primary reaction chamber, which are very similar to the shaft system inside of the Queen's Chamber of the Great Pyramid. These shaft systems lead from the primary reaction chamber diagonally up towards the external side of the structure. They do not go to the outside of the pyramid, and I cannot find a single diagram that has these shafts indicated, but I do want to show you pictures because they are absolutely located inside of the structure. So you can see here, this is a picture of me from my 2021 research expedition looking up at these square terminations of these shaft systems. And to my knowledge, these shaft systems have not been explored or excavated to the same extent as the shafts inside of the Great Pyramid. So I believe it still remains a mystery of exactly what is inside of these shafts and where they go. All I know is that they don't go all the way to the outside of the structure, very similar to the pair of shafts that are located inside of the Queen's Chamber of the Great Pyramid. All right, next up, here we have a laboratory apparatus configuration that is designed to produce hydrogen chloride gas by reacting sulfuric acid with sodium chloride. And this is the exact same process and the exact same configuration that you will find inside of the Central Pyramid of Giza. So here you have your dropper that is utilized to introduce your sulfuric acid into your primary reaction flask. You can see here that your reaction flask has been filled with sodium chloride. So the sulfuric acid pours down onto the sodium chloride. This reaction releases the HCl gas. The hydrogen chloride gas flows through the connecting tube, and it is deposited here into your collection vessel. Now, if you had water filling this collection vessel, that would then produce a hydrochloric acid solution as opposed to collecting the dry hydrogen chloride gas. Now, let's compare that laboratory apparatus configuration to the components of the central pyramid. So you can see here, this is your reaction flask or your primary reaction chamber that has been filled with that sodium chloride solution. Your sulfuric acid is introduced into the primary reaction chamber, reacting with the sodium chloride to release hydrogen chloride gas. That hydrogen chloride gas then flows through your connecting tube, i.e. shaft system, all the way here into your collection vessel, i.e. your extraction chamber. And water from the external reservoir was introduced into your collection chamber to create that hydrochloric acid solution as opposed to collecting the gas directly. So again, you can just see the comparison between the reaction flask, connecting tube, and collection vessel that you see in your laboratory apparatus configuration with the configuration that we find inside of the central pyramid. So now I am going to show a video that demonstrates the chemical reaction that was occurring inside of the primary reaction chamber. All right, ladies and gentlemen, before we proceed with the technical details, allow me to reiterate 2 points. First, I propose that the chambers inside of the Great and Central Pyramids were coated with a chemically resistant sealing compound which protected the stone from the vitriolic effects of the acidic solutions that we are discussing. Secondly, these acidic solutions were incredibly dilute, and they were immediately removed from the extraction chambers to mitigate any potential for damage to the internal components of these structures. So generally speaking, in regard to the function of the Egyptian pyramids, in order to better understand how these structures may have originally operated, you have to evaluate them from a completely different perspective. And that is exactly what I did when I began to develop the theory that the Egyptian pyramids were designed to produce chemicals on an industrial scale. These were no longer stone burial chambers, but they were individual components of a manufacturing sequence. These are reaction chambers. This is a pump shaft. And here, for example, in the upper vault of this primary steam reformer, this isn't just some fancy vaulted ceiling. This is actually a functional piece of architecture that operated like a compressor mechanism inside of your reaction chamber. So you can analyze these structures on a large scale as being broken down into individual components of a manufacturing sequence. Or you can also evaluate these structures on a small scale as being comparable to a laboratory apparatus setup that is designed to produce the exact same chemical reaction. So you can see here, instead of your stone chambers, you actually have glass reaction flasks. Instead of stone shafts that connect your chambers, you actually have connecting tubes. Instead of your extraction chambers, you actually have glass collection vessels. So the Egyptian pyramids can be analyzed not only on a large scale as being comparable to industrial manufacturing processes, but they can also be evaluated on small scale as being comparable to a laboratory apparatus setup, and that will give you a better picture of exactly how these structures originally operated and the intention of each individual component of the structure. So now that you can visualize the chemical reactions that were occurring inside of the primary reaction chamber, let's just review this chemical equation with the reactants and products so that you can fully understand the chemical reactions that were occurring during this manufacturing process. So your sodium chloride solution is introduced into your primary reaction chamber. This is a saturated solution. The water is allowed to evaporate, leaving a deposit of solid sodium chloride. And we have found that deposits of sodium chloride were found all over the inside of the central pyramid, which have now been removed in the renovation efforts. So your sodium chloride reacts with your sulfuric acid. Recall that your sulfuric acid was being produced inside of the Great Pyramid and then introduced into the primary reaction chamber of the central pyramid. These two chemicals react to release your hydrogen chloride gas. As I mentioned before, that hydrogen chloride gas flows through the connecting shaft system towards your extraction chamber, where it is mixed with water to create a dilute solution of hydrochloric acid. You will also see that there is a byproduct created in this manufacturing sequence of sodium bisulfate. That sodium bisulfate will remain in the primary reaction chamber until it is collected in the ultimate portion of the manufacturing sequence. And now I'm going to insert a video of a laboratory experiment which demonstrates this exact same chemical reaction occurring in small-scale laboratory apparatus. Now, all you have to do is scale that up to the size of the Egyptian pyramids, and then you have the manufacturing sequence that was occurring inside of the central pyramid.
After having put around 1 centimeter of salt in your test tube, put back on your pipette with a concentrated sulfuric acid. Use a tube like this to make an airproof connection between your test tube and a water with your magnetic stirrer to make sure that the gas will go from here in the water. The magnetic stirrer is not absolutely necessary, but it's a good thing to mix up the water with hydrochloric acid later. So if you have one, turn it on now and go on with the next step. Now put some pressure on your pipette so that the sulfuric acid will drop down on the salt, and you will see that a gas is coming out of here and getting here in the water. It's an exothermic reaction, so the test tube will turn a bit warm. This wasn't enough. Take some more salt or sulfuric acid and drop it down again. The reaction will go on and more hydrochloric acid will be produced. The pH meter, which first showed a pH of around 7, now shows a pH of 2.6 because the hydrochloric gas in the water makes an acid solution. Apart from the hydrochloric acid, there's also sodium sulfate produced with this reaction.
And just a quick citation for the two videos that were used in tonight's episode. The first came from the Homemade Chemistry YouTube channel, and the second came from the Natural Science YouTube channel. Links in the video description below. All right, so now that you can visualize the entire chemical manufacturing process occurring, now let's apply what you saw in the video to this configuration of the central pyramid. So you have here your reaction flask on the left, you have your extraction vessel here on the bottom, and you have a connecting tube which links those two vessels. So here in your primary reaction chamber, you are going to fill the lowered portion with sodium chloride. You are then going to introduce your sulfuric acid solution into the primary reaction chamber, which will react with that sodium chloride to produce hydrogen chloride gas. You can see here in green, this is your hydrogen chloride gas flowing through your connecting shaft system down towards your extraction chamber. Now, there are three flushing mechanisms that are involved in the operation of the central pyramid. So the first flushing mechanism is going to be here through your lower reservoir intake shaft. So once you open up this stone valve, it will allow water from the reservoir to flow through this shaft system towards your collection chamber, and this will facilitate in collecting the hydrogen chloride gas into an aqueous solution of hydrochloric acid, which is then immediately removed from your extraction chamber. The second flushing mechanism is going to occur here in your upper reservoir intake valve. If you open this stone valve, it will create a fluid dynamic flowing water system that moves from your reservoir down this sloping section here, down towards your extraction chamber. And what this is going to do, it will draw any hydrogen chloride gas that is remaining here in your reaction chamber or in this connecting shaft. It will draw that gas out of this area into solution, which is then extracted here from your collection chamber. The third flushing mechanism that is involved in the operation of this structure is to remove the water-soluble sodium bisulfate solution from your primary reaction chamber. So if you close this lower stone valve here, introduce water through your upper reservoir intake shaft, it is going to infill this entire system, filling this primary reaction chamber with water, dissolving the sodium bisulfate that is remaining in this chamber. That solution is then extracted through this extraction shaft here, which I showed in the previous slides. That sodium bisulfate solution is then removed from your primary reaction chamber, and the entire system is flushed with water in preparation for the subsequent production cycle. So now we still have a few unanswered questions regarding the function of the central pyramid. So what exactly was the use for the hydrochloric acid? How were they utilizing the sodium bisulfate that was collected from the primary reaction chamber? How were these acidic solutions collected, transported, and stored? What was the purpose for the massive body of the pyramid itself that sits above these reaction chambers? All of those excellent questions definitely have an answer, and you'll just have to stay tuned here on the Land of Chem. And just a quick reminder that limited first edition print copies of the Land of Chem book are finally available at www.thelandofchem.com. This is an absolutely beautiful first edition print copy of the book. There's purple metallic foil stamping on the exterior cover. The interior body pages are orchid, and I am so proud of how this book turned out. So if you want to help support the channel, just go to the website. You can pick up your copy of the book, grab yourself a Land of Chem t-shirt. Either way, all of the orders mean more to me than words can possibly ever describe. So I will simply say, thank you. All right, everyone, that is it for today's video. This was episode 26. Hydrochloric acid, Central Pyramid of Giza. I really hope you enjoyed today's episode. If you like it, leave it a like. If you haven't already, definitely subscribe to the Land of Chem here on YouTube and click that little notification bell so that you get noticed whenever these videos premiere. If you have any questions, comments, feedback, please leave that in the comment section below. I genuinely enjoy interacting with everyone in the comment section and hearing what you think about this material. Also, if you have any suggestions for future videos, leave that in the comment section below as well, and I will try and add those to the queue. So for my next couple of episodes, I have some really fascinating research coming up, so just stay tuned. Just want to say a quick thank you to all of the new subscribers here on the channel and to everyone that's recently purchased a copy of the book. It means more to me than I can possibly ever describe. Thank you so much. I think that is it for today's episode. So I will see you next time.